Good
Yeah.
morning, ma'am.
Morning, ma'am.
Yes.
Good morning, ma'am.
Yeah. Good morning. Still, few of the students have not joined the Google Classroom. Around 11 students. So please join today itself. I've started sharing the PDF material with you all on that Google Classroom. Okay, the one which I have shared in your WhatsApp group. Fine. So today we are going to start with unit number 1, that is ordinary differential equation, formation of differential equation, and solution of differential equation. So there are two parts. The first part is formation of differential equation, and the second part is solution to differential equation, which has different methods by which we can solve them. Okay. So let us start with the prerequisite, or what is required basically for solving the differential equation. What is the meaning of differential equation, that we'll see. Then we will also see what do you mean by solution of differential equation, and then how do we form the differential equation in today's lecture. We will do this in short because in the flipped classroom you will be doing in depth. Okay, so let's go about it. So the first thing is, what are the formulas? Integration formulas I've already shared it on your Google Classroom, but still the ones which are used frequently I'll just revise them. One of them I can solve also, and then we will go to the differential equation. So integration formula which will be required, and the first one is by parts. Okay, integration of u into v with respect to x into this. Now do you remember the formula? What do we do? We write u into,
U
yeah, say
one
integration v dx. Just because we are writing in your notebook simultaneously so that we revise it also. U integration v dx minus integration of derivative of u into integration of v, and one more time again. This is by parts. Can everybody see what is written on the board? Integration of u into v is nothing by parts. It is u integration v dx minus integration of derivative of u into integration of v, and one more time whatever the answer of that inside function, uh, integration of that. Is this okay? That's the formula. Okay, but many a times it becomes easy to use the Bernoulli's formula. This is Weismann's formula. The Bernoulli's formula is nothing but you have to, you will remain as it is. First integration of v minus u dash, second integration of v plus u double dash, third integration of v, and minus plus alternately so on. So derivatives are also denoted by this dash. First order derivative is in dash, second order derivative is in double dash, and so on. So this we have used in Fourier series. So maybe sometimes we'll be using it here also. So u v1, u as it is, first integration of v minus u dash, second integration of v, u double dash, third integration of v, and so on. Okay, fine. So this is the first formula. Second formula which will be very frequently used is f dash of x upon f of x. Yes. How do we solve this integration? We put f of x is equal to t, then f dash of x dx becomes dt, and it becomes dt upon t. Derivative of t is on top, and therefore the answer is log of t. But what is t? Log of f of x. T is f of x. So this is your formula. Is this correct? Clear to everyone? These are the basic formulas. I'm just revising it because they are going to be used very frequently to solve the differential equation. Okay, everyone.
Yes,
yes,
ma'am.
ma'am.
Yes,
Yes, ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Then
Yes, ma'am.
now this formula again will be used because when you will be solving the differential equation, you come across, if it is in first order form with differential equation in polynomial, you will many times come across such type of integration, polynomial by polynomial, whether degree of numerator and degree of denominator is same. So how do we solve this? I can give you the formula, but how do we generally solve this
Ax
polynomial?
plus b can be written in some form of cx plus d.
Absolutely, that's what we do. Okay, so I'll solve it also for you because this is what we will come across many times when we have first order, first degree differential equation, and it is having only x, that is independent variable of power 1. So most probably you come across such type of integration. So what we said is absolutely right. You have to adjust the denominator and numerator. So you can see here cx plus d. How can you do that? A is as it is. You have to write cx plus d. Okay. So what is extra with x? C. So that will be out. Isn't it? Okay. And then what is again your extra? AD by C. So minus AD upon C. And what is left out? P is left out. So plus B divided by Cx plus D. This is the general method. I am solving this purposely so that whenever you come across such type of integration, this is the technique that you have to use. Okay? Fine. Okay? So what I have done? I have adjusted Cx plus D on top, but I have done Ax. So I have to get Ax, so that's why divide by C, multiply by A by C. But when I multiply A by C with D, A into D upon C is extra, so I have to subtract that, and this D was not written, so plus B. Now you do the actual division, it will become integration A by C dx minus, if I add minus sign outside, it will be AD upon C minus B. Okay? Into integration of 1 upon Cx plus D
Plus D.
dx. Is that okay, everyone?
Yes, ma'am.
Yeah. And now we do the actual integration. The first integration is what we see. It is constant term. What is the integration of constant term? A by C is as it is. Integration increases the power of x. Here there is power of x to 0. X raised to 0 is there. So it will be increased by 1. So what is actually the power
X.
of x? This is x. Okay? Minus. Now this AD by C minus B is as it is. What about this term? Integration of 1 upon Cx plus D. What is the integration of this?
Log Cx plus D.
Yes.
Log Cx plus D.
Log of
Yeah. Is that the final answer? Log Cx plus D. What I'm using? I
No,
told you that.
plus 1 by
log.
I told you that.
1 by C.
Correct, absolutely. Right. I told you that this formula will be used many times. F dash upon f of x. What's the derivative of Cx plus D? Those who are not understanding. Cx plus D का derivative क्या है? D is a constant, derivative is 0, Cx derivative is C. So that should be present on top. So I have to adjust that. So what we'll do is 1 by C integration C, 1 by C integration of C upon Cx plus D dx. And now it will become A by Cx minus AD upon C minus B into 1 by C integration of this is log of Cx plus D plus the constant of integration C1. Okay, so if you rewrite it in proper format, just see. This is A by C, you can take common, it will become X minus, if I add it plus, this will become, B will come first. So it is B by C, B by C. Okay, and then A by C I have taken common, so it will become, I will this, so minus B by C into log of this bracket multiplied by log of Cx plus D plus C. Is this clear? This is the formula. Remembering this formula will be quite lengthy. Can you see that? Is this possible to write, to remember A by C and so on? So I told you the method. What you have to do? You have to adjust the denominator with the coefficients and then you get the answer. If you are able to write, remember the formula, it is A by C into X plus B by C minus B by C. Yes, one more thing I think so we have skipped. What is that? Something is, yes, something is wrong here. I have taken A by C common, now there is no A by C over here. C is there, but A is not there. So it is A, B by A, not B by C. Cross check everyone.
Ma'am, there would be the negative sign in between. Like,
Here,
yeah, yes, ma'am.
why I have not written it plus, so this B which was minus of minus plus will come first, na? And this I have written minus.
Okay, okay.
Okay?
Yeah, got it.
And this I have written B by C, but B by C I have taken A by C common outside. A by C was not here. C is there, but A was not there. So I have to divide by A. Is that clear?
Yes, ma'am.
Any doubt to anyone? Please ask. Okay? So rather than
Yes.
remembering this formula, you remember the method of doing it. Because how many times you have learned such a big formula and then if the formula is asked, deriving it within 1 minute or 30 seconds will be lengthy. So if you are able to remember very good, else you can do it. 30 seconds, if you practice, it will be possible. Okay? Right? Yes, so this formula is going to be useful many times. Then let's go to the next formula. I'm taking it. Last time we didn't take formulas directly well, and few of the students have requested that please take some of the integration formulas at least. So I have taken it here, which will be used very often. And let me tell you one more formula that is of e raised to x. Integration of e raised to f of x into a dash of x dx. Yes. Can anybody tell me what will be that? How will we solve it? Put f of x as t. Put f of x as t, then f dash of x dx will become dt. I write it here. Put f of x is equal to t, then derivative of f dash of x dx will become dt, and later this integration will become e raised to dt. And this integration is just e raised to t plus c1 or c. So our answer is e raised to f of x plus. Clear?
Yes, ma'am.
Yes.
And the last one which will be there in your what to say will be there in your electric circuit. That formula is e raised to x. This we have done last time also. E raised to x cos of dx dx, which is e raised to ax upon the root of a square plus b square into cos of dx minus phi, that phi is equal to 10 inverse of phi. This will be the formula. This formula will be used for your electric circuits. Okay. If there is sine dx, then there will be sine. Where phi is equal to 10 inverse of phi. Okay. This formulas will be used. So these are the integration formulas. First and second unit specifically has only integrations. Derivatives are sometimes those preliminary or those normal derivative formulas which are there. And obviously, you should know the integration formulas of x raised to n, then 1 upon x, or how do we get log x integration. All those things you should know. Okay. So now let's go to the actual topic, that is differential equation. So what do you think a differential equation is? We have already discussed in short in yesterday's lecture. What is a differential equation? Quickly, whatever comes to your mind about differential equation, at least the literal meaning of differential equation. Let's start from roll number 1, division C. Jay, you are there? Roll number 1, division C, you are there? Jay? Palak? Don't be present just physically over there, or rather just your roll number. Be present actually and really also. Roll number 2, division C, Palak. Roll number 3,
Yes, ma'am.
yeah. What comes to your mind when it is differential equation?
Uh, I would say equation where you solve and plug in values and you get the actual answer.
But what should be there? Basically, what should be there? I
Like
think
you should have
derivative should be there, na? Differential equation. So it should have differential
And there are two
coefficient.
variables in one
Okay,
independent variable
very good. So
and one
Apurva raised the
dependent,
hand. Very good, very good. You should
and
have
there is
something
a
called
differential equation. And
derivative.
ma'am,
There should be derivative.
it can be expressed in a fractional form and radical sign constant.
They should not be there.
Yeah, not.
For finding the order and degree, that is one of the thing. But before going to radicals, fractions, and all those things, first of all, there should be something called as dependent variable, something called as independent variable, and something called as change, rate at which it is changing. Okay, so derivative. What is the basic thing which should appear in an equation which will be somehow called as differential equation? There should be derivatives. For taking the derivatives, there should be dependent variable and independent variable. So dy by dx, that's what I have done. Rate at which the value of y is changing with respect to x. Then slope, that is an example. Velocity is an example. Acceleration is an example. Wherever there is rate of change, population growth, rate of decay, all these are nothing but differential or derivatives. Okay, and those when put up in an equation, that is, it has left hand side, it has right hand side, it has dependent variable, independent variable, that is called the differential equation. So basically, you have something like y is a function of x. Then we can talk about dy by dx. That is, what is the change in y with respect to x? Dy is small change in y, that we have done in M1. Dy means small change in y. Dx means small change in x individually. But when I write dy by dx, it is the change in y with respect to x. Okay? So for example, dx by dt, change in the distance with respect to time. D2x by dt square. That is acceleration. Okay, so that's the reference. So dy by dx, if it has y is your dependent variable, x is your independent variable. But when y depends on or z depends on more than one variable, then what we have done? Who can tell quickly? Roll number 4,
Partial,
Mustafa. Yeah, yeah. Right.
partial derivative.
Correct. There was zy, there was x, and there was zy, there was y. So these are also derivatives, but they are partial derivatives. So a differential equation can have ordinary derivative, those are dy by dx. This is first order. d2y by dx square is second order. d3y by dx cube is third order, and so on. The notations also used are y1, y2, y3, and so on. Or y dash, y double dash, y triple dash, and so on. These are the notations. So your examples in your university exam may be of this type, either d2y by dx square or y2 or y double dash. Partial derivative, delta z by delta x, delta z by delta y. Second order derivatives are delta square z by delta x square, delta square z by delta y, delta x. These all we have done partial. Okay, so these are differential coefficient, either derivatives or they are called as differential coefficient. Y is a dependent variable, x is a independent variable. When we put this together in an equation, it is called as a differential equation. dy by dx plus x is equal to 0. dy by dx plus y is equal to 0. dy by dx plus xy is equal to 0. So this is your differential equation. Is it okay? An equation which has derivatives can have independent variable, dependent variable, no arbitrary constant. Powers of the derivative should not be radical or fraction. Even integration should not be there in the question. If you write integration, something like integration of dx is there, then that differential equation, the order will not be identified properly. Because integration, if I remove it, the order will increase. That's why in the equation there should not be any fractions or radicals of the dy by dx. There should be no arbitrary constant and there should be no integration signs. Okay, so that is a differential equation. So you can write down the definition because sometimes it is asked for 1 mark. An equation, please write quickly. An equation that has derivatives, dependent variable and independent variable, and an or. Not necessarily it should have only independent variable, is called a differential equation. Is called a differential equation which has no arbitrary constant. Which has no arbitrary constant. They mention who is, if there are suppose letters A, B, C, and if they have not mentioned, then all A, B, C are arbitrary constant. If it is mentioned that A and B are fixed constant and C is arbitrary constant, then you will treat only one as arbitrary constant. What is the relation of that with the differential equation, that we'll see a bit later. Okay, so that is the definition of differential equation. Now it has two. Yeah.
Ma'am, after is called differential equation. What was it?
Is called differential equation, which is free from or which is free from arbitrary constants. Which is free from arbitrary constants. Okay. So
Yes, ma'am. Thank you.
yeah. So arbitrary constant means what? Just now I told you, like there will be alphabets, letters, and those are actually obtained when we solve the differential equation. When we do integration, the integrate constant of integration comes into picture, and that is a general arbitrary constant. That is nothing but what I was talking about. Okay, so this is the differential equation. Now there are two parts. You know differential equation, you should know the solution. What is the solution of this? How do you go about it? Dy by dx is equal to minus x. That is, dy can be written on one side, x can be taken along with dx, and it is called as variable separate. Separate the variables. Along with dy there should be y, along with x there should be dx, and you solve. So what you get? Dy is equal to minus x dx. Correct, na?
Yes, ma'am.
So what is the
Yes, ma'am.
how will you get the solution then? Just integrate on both sides, and since you are integrating it once, you have one constant of integration which is c1. Okay? And now do the integration. D and integration, they are empty of each other, so they cancel out. And therefore you get 1 is equal to minus. What's the
Square by
integration of
2
x? Yes, x square by 2. And x plus.
plus c.
So y is equal to minus x square by 2 plus c1 is the solution of this particular differential equation. Is the solution of this particular differential equation. Is it okay?
Yes, ma'am.
So there are two ways. From the differential equation you can go to the solution, and from the solution also you can go to the differential equation. So what you will do? If you want to go from solution to differential equation, what you want to do?
Take the derivative.
Very good, absolutely.
Derivative.
जैसे आए थे वैसे ही रिटर्न जाना है. डिफरेंशिएशन से इंटीग्रेट करके आंसर आया था, तो आंसर से डिफरेंशियल इक्वेशन से कब तक कैसे जाओगे? डू द एंटी ऑफ इट. सो इंटीग्रेट किया था तो उसका एंटी है डेरिवेटिव. सो टेक द डेरिवेटिव एंड गेट द आंसर. Okay, but how many times are you going to differentiate? It can happen that single time if you differentiate you get the answer. You get a derivative equation, as well as if you do two times integration. Differentiation can also you get. So how many times you differentiate? That will depend on
Number of constants.
absolutely right. It will totally depend on number of arbitrary constants. So that's the relation between your solution and the order of the differential equation. What is the meaning of order? How many times you differentiate? So that I come to. That is the next one, order of the differential equation. So C1, your constant which is there, will tell you how many times to differentiate, because you have derived only one arbitrary constant. And then you get a derivative. And obviously this arbitrary constant is gone. Whatever remains is the derivative and dependent variable and independent variable. And that will be a differential equation. Is it okay? Fine. So if fair enough idea you have got. Now we will go to in depth. What do you mean by order of the differential equation? What do you mean by solution of differential equation, and so on. Okay? Clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
So let's go to now. You write down some examples. I send you the notes. Okay. In that the examples of derivatives, differential equation of ordinary and partial. So there are two basic streams of differential equation. Let me just write it down. Differential equation is divided into two parts. One is ordinary differential equation and the other is partial differential equation. Okay, so partial differential equation we have done in last semester. Okay, ordinary differential equation is what we are going to do now, and higher order partial differential equation we are going to do in M2. Here also M3, sorry. In first year M2, ordinary differential equation we are going to solve of first order first degree. Second order second degree again you are going to do in M3 first unit. Okay. So what do you mean by ordinary differential equation? It has ordinary derivative dy by dx, d2y by dx squared, and so on. And what about PDE, partial differential equation? It will have gamma z by gamma x. It will have gamma square z by gamma x squared, and so on. Okay, so depending on the type of derivatives you are writing in the equation, it is either ordinary differential equation or partial differential equation. But order and degree of both the type is defined in the common. Okay, so let us go to definition of order of a differential equation and degree of a differential equation. One of the student among you all is going to take in-depth what you say examples of order and degree. I'll just give you in short what is the meaning. One or two examples I'll do, then she will explain in the flipped classroom properly. Okay, so let us go to what's the meaning. So what do you think? Again, let it come from your whatever knowledge you have. What is the meaning of order of a differential equation?
The highest
Yeah,
order of any
Number of
differential
arbitrary
coefficient.
correct. It is the order of the highest derivative in the differential equation. But in that case, what will be the thing? Order actually won't be affected with the powers of fraction and all. Degree will be affected. But still, the entire differential equation should be free from radicals, free from fraction powers of the derivatives, and free from integration sign. Okay. So order of a differential equation, I'll just tell you, and you can write it from the notes later on. You can write down simultaneously also. Order of the differential equation is order of the highest derivative appearing in the differential equation, order of the highest derivative appearing in the differential equation, free from radicals, fractions, integration sign. So I'll just give an example. Rather, I'll
Can you
define.
repeat it, please?
I'll repeat it. Order of a differential equation. Order of a differential equation is the order of highest derivative. Order of highest derivative in the differential equation. In the differential equation. Okay, I will give the examples a bit later. Let me first define degree also. Degree means what?
Power of highest derivative.
Correct. How many times we are differentiating it is order, and the power of that highest order derivative will give you the degree. Okay, so you write down that also definition. Power of the highest order derivative. Power of the highest order derivative in the differential equation. Power of the highest order derivative in the differential equation. Free from radicals, fractions of derivatives, free from radical fractions of derivatives, and integration if involved. Why that you have to remove radicals and fraction? Can anybody just think about it? Why that radicals or fractions of the derivative should be removed?
And because of that, the power value of the power changes now.
That is the output. You remove it, then the power changes. Actually, you tell me what is the meaning of 1/3 derivative of the function. There is no meaning to fraction derivative. Na? That's why those should be removed. Getting it?
Yes, yes.
And once you remove that, then you get the proper order and proper degree. Okay. So now, is that clear what I mean by degree? Suppose you have d2y by dx square and the power of d2y by dx square is 3. And that is the highest power. That is called as degree of the differential equation. So I'll give you some examples now quickly, and then you tell me what is the order and degree of it. Okay. So the questions which are there in MCQ also, I'll share you the MCQ set on this particular topic also today. So now this is the differential equation which is given to you. Can you see everyone? 1 plus dy by dx minus d2y by dx square the whole raised to 3 by 2. So that 3 by 2 is the fraction and we have to remove it. So 1 plus dy by dx will become equal to d2y by dx square the whole raised to 3 by 2 and I have to remove this fraction 3 by 2. So what is the fraction? 1 by 2 is the fraction. So I square both sides. Are you getting it? Yeah. So then 2 and 2 will get cancelled and I'll get 1 plus dy by dx. The whole square is equal to d2y by dx square whole is to 3. Quite simple example. Okay. Now tell me what is the order.
Order is
degree
2 and
Order
Order
2
2 and degree
two
Order
and
is 2
degree 3.
and degree
Degree is 3.
Everyone very easy because who is the highest order derivative? कितने बार differentiate किया है सबसे ज़्यादा? 2 बार d2 by dx square 2 times. So order is 2 and what is that power of d2 by dx square highest power 3. So degree is 3. Is it okay? I'll give you one more example quickly. Say 1 plus dy by dx is equal to x upon dy by dx. What is the order and degree?
1.
Both 1
1 2 1 2
Yes,
1 2
yes. It
1
cannot
2.
have dy by dx here in the denominator. Remove the radicals. Okay. So what will minus 1? dy by dx minus 1 is there. So you take it this side. So it will be dy by dx plus dy by dx into dy by dx is dy by dx the whole square. Are you getting it? Don't directly look at it and say that it is 1 1. You have to write it in the proper format. So what is order? Order is fixed. That's one. But degree is not 1, it is 2. What is the highest power of the highest order derivative? 2. So degree is 2. Is this clear?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes,
Any
ma'am.
doubts to anyone? Please ask. Okay. Fine. So I will share more examples on this with you all. But is basic concept clear to you? I'll take one more example of integration. Okay. This is second. This is first. And the third one, let me take it. dy by dx plus integration of x dx is equal to say x square. This is our equation. Find the order and degree of this. Then what you want to do? If you keep this integration as it is, then this has integrate. This has what you say. This will change the order of the differential equation if I try to remove it. Integrations are not allowed. So how will you remove this integration? Can anybody guess? Because I don't think so. Such type example you did earlier. If you have done, please tell.
By differentiation.
Differentiate.
Differentiating method.
Yes, you have to differentiate it. Very good, very good. And we enter in the class, okay, so that you will enjoy. So if you differentiate it, it is d by dx of dy by dx plus integration x dx is equal to derivative of x square, that is 2x. Okay, and therefore, what will you get is this. You will get d2y by dx square, d2y by dx square plus d by dx of integration x dx is equal to this. So derivative and integration cancels, dx and dx cancels, and then your equation is d2x, d2y by dx square plus x is equal to 2x or minus 2x is equal to 0. Okay, and therefore the order of the differential equation is 2 and degree of the differential equation is 1. Okay, highest order derivative क्या है? Second order का derivative. What's the power of that? The power of that is 1. Therefore the degree is 1. Clear? Everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah. So these are some examples. I'll share more examples with you in the Google Classroom. You try to solve them. Yeah.
Why can't we write the value of integral x dx as x square by 2 and then solve?
If you write the
Answer
yeah,
will
yeah.
be same, huh?
Yes, because you have to remove. If you want to form the differential equation, then you have to do it.
But integral x dx is an independent term, na? So writing the value
Yes,
of x, integral x dx can also be x square by 2.
Ma'am, it will give one constant also, na, with that. It is not definite integral.
Oh,
So
okay.
what to do?
And then you have to find that c, and
Yes.
then you have to remove that c, and you have arbitrary constant. Are you getting it? Very good.
Okay. Got it, ma'am.
Okay, got it. Is that clear for the remaining students also? What solution? Who told that answer?
Me, ma'am.
Yeah, you said me. I can't see you.
Atharva.
Atharva, yeah. So understood why the integration is necessary? First reason was if you don't remove it, then your order degree and order will be different. That is the conclusion. But why? If I do the integration, then your integration will be x square by 2 and it is not definite integration plus c will come. And in the definition of differential equation, we said it should have no arbitrary constant. You'll have to remove that arbitrary constant. That means again you have to what you'll have to do differentiate. So your order will become again 2. So rather than doing that first and then doing it, one and the same thing. Getting it?
Yes, ma'am.
Okay,
Yes.
fine.
Yes,
Fine.
ma'am. Yes.
Okay, so that is about order and degree. Sharvari, you are there? Sharvari Patil?
Yes, ma'am.
Yeah, so I will share the topics which you have to take in the classroom, and maybe on Friday we will take it. Okay?
Okay, ma'am.
Yeah. Yes. So this is order and degree. Now let's go to solution. Did I give the definition of solution of differential equation?
No, ma'am.
Yeah. So from this, let us just go to solution of differential equation, and then we'll go to formation of differential equation. So if your differential equation is dy by dx, I did this last time also, na? Yes. If dy by dx is equal to sin x, what do you mean by solution? Which is the function y in terms of x which satisfies the differential equation. Is this a differential equation now? It has derivative, it has dependent variable, no arbitrary constant. So how will you find the solution? We did it in the previous part also. We will integrate it by variable separately. Which variables are there? Dy, y is the variable and x is the variable. So this is sin x dx. Integrate this constant of integration c1. Therefore y is equal to integration of sin x is
Cos x.
Minus
Cos
minus
x. Minus cos x.
Minus cos x.
please don't do those mistakes. Derivatives and integration getting confused. So minus cos x plus c. Okay. So this is your solution. What is the meaning of solution now? Relation between the dependent variable and independent variable. Okay, will satisfy the given differential equation. Now, if the C1 was not there, is still y is equal to minus cos x the solution?
Yes.
Yes.
Ma'am.
So C1 is not there
One of
is
the solutions.
correct, absolutely.
C1 is 0.
Yeah, C1 is 0. So that is called as particular solution. And when C1 is there, C1 can take any constant 1, 2, 3, 4, 0, minus 1, minus 2, minus 3, anything. That time it is called as general solution. So whenever arbitrary constant is there, it is called general solution. And wherever the arbitrary constant is taking a fixed value, it is called as particular solution. Okay. So in the notes, these definitions are given. So basically, what is the meaning? Is it clear? A relation between dependent variable and independent variable with number of arbitrary constant equal to, listen to the statement carefully, with number of arbitrary constant equal to order of the differential equation is called general solution of the differential equation. Is it okay?
Yes, ma'am.
I'll repeat.
Yes, ma'am.
Yeah, relation between dependent and independent variable. Y और x के बीच का relation, okay, which has arbitrary constant. इसमें arbitrary constant है. कितने arbitrary constant है? Equal to the order of the differential equation. What is the order of this differential equation? कौन से highest order का derivative है? dy by dx. So it has only one order derivative. That's why the arbitrary constant is 1. So the solution which has arbitrary constant is equal to the order of the differential equation relating dependent independent variable is called general solution, and if C1 takes particular value, it is called as particular solution. Okay, fine. So the second part which is there, going from differential equation to solution, has variety of methods. So one of them is variable separable that we all have done. Yeah.
Definition एकदा repeat करता का परत? Relation between dependent and independent variable having
arbitrary constant, number of arbitrary constant, having number of arbitrary constant equal to order of the differential equation, equal to order of the differential equation is called general solution, is called general solution of the differential equation. General solution of the differential equation. If C1 takes particular value, if C1 takes particular value or constant, then it is called particular solution of the differential equation. Can it be in terms of x, C1?
No.
No, then your answer won't satisfy because it should say, yeah, obviously did I say satisfy? That also should be there. Huh? Relation between dependent and independent variable having arbitrary constant equal to order of the differential equation and satisfying the differential equation. That's the most important thing. And satisfying the differential equation. Okay? It's called general solution, and if C1 takes particular value, it is called as particular solution. Okay. So going to the second method, that is from differential equation to solution. There are a variety of methods. First one is variable separable. Then we have exact differential equation, linear differential equation, but homogeneous, Bernoulli's, all those we have. So that will go on a later stage. First we'll go from solution to differential equation. That is called as formation of differential equation. That is called formation of differential equation. So let me just tell you how do we form a differential equation when we are given the solution. Can anybody just think about it, how we are going to go from the solution to the
And
differential equation?
we have to differentiate
So we will
the equation.
differentiate the solution.
Yeah, we have to differentiate, and what we have to do? Why are you differentiating?
And so that we will get
Ma'am,
that differential coefficient.
eliminate that
Also, the
Yes.
constant will
Plus
be
we
to
will
eliminate, ma'am,
eliminate the
arbitrary
arbitrary
constant.
eliminate the
constant.
arbitrary
Very good, very
Constant.
good, very good. I'm just liking it. Okay, you all are giving so much of response. That's excellent. But please see to it that everybody is giving the answer. Write down in your chat box also, if it is possible for you, the reasons. See, one of the reason is we want derivative. If I want differential equation, I want derivative. So I have to differentiate. Secondly, if I want to, what do you say? If I want to get a differential equation, it should be free from arbitrary constant. So
Arbitrary constant.
yes, very good. To remove the arbitrary constant, we should differentiate it. Okay, that will tell you till which step you have to differentiate. How many times you have to differentiate? Just now we said that yes, to get the derivative and remove arbitrary constant. Yes, Dishika, you're right. So how many times to differentiate will depend on the number of arbitrary constants. Are you getting it?
yes.
So that's why these arbitrary constants are very, very important, and the statement saying that number of arbitrary constants in the general solution gives us the order of differential equation. So those many times you have to differentiate. Okay. So just see, if I differentiate this, I get dy by dx is equal to minus is everything, derivative of cos x is minus sin x, and derivative of c constant is 0. Therefore, a differential equation is dy by dx is equal to sin x. This is simple. You go to the complicated ones also. But is that clear? I have to differentiate the given equation how many times? Number of times equal to number of arbitrary constants. Okay. So you write down the heading as formation of differential equation. Formation of differential equation. Step 1, given general solution to form differential equation, identify number of arbitrary constants in G dot S. General solution henceforward you can write G dot S. समझ में आ रहा है ना सबको? First step is, in the given general solution, identify number of arbitrary constants in GS, general solution. In step 2, differentiate the given solution number of times equal to number of arbitrary constants. If those constants are individual, वो अकेले अलग है, उसके साथ कोई भी dependent variable या independent variable नहीं है, then the elimination is easy, isn't it? Because derivative of the constant is 0. But if there is x along with that, then the elimination won't be straightforward. Can you see that? For example, if we have y is equal to c1x, y is equal to c1x squared. This is your solution. Y is equal to C1 x square is your solution. Then what you are going to do?
Differentiating again and again.
Differentiating
No,
twice.
no, no.
And then we can differentiate
Ma'am,
one
that's
time.
You have to
Y by
differentiate
x
it only
square is equal
once.
to C.
One time.
Correct. C1 and plus C1 again it is written suppose, or C1 square and plus C1, something like this. Otherwise you take C1 common and write it again. So C1 square and C1, okay? But still, how many arbitrary constants are there? Only one arbitrary constant.
Yes.
So order of the differential equation should be one only.
One only.
Getting it? So you have to get the value of C1 by differentiating it once. So you can write dy by dx is equal to C1 square into 2x plus C1 is gone. So what's the value of C1 square? C1 square is
dy by dx
dy by dx upon
2x.
this value you can put it here and get the value of C1 and its square.
Ma'am,
Huh.
and instead of dy by dx we can write y1 also.
Yes, you can write this way also, y1 also. Because it looks very lengthy, you can write this way also. Or you can write this way also, y dash also. Is it okay? We'll do this type of example. So is this clear? It doesn't mean that there are two times C1 is appearing, so you have to differentiate twice. That will be a wrong answer, and that will be present in the option. So please don't select that. What you have to do, you have to differentiate only once, and you have to do the elimination. Okay, fine. So what I told you, first identify the number of arbitrary constant. Second, differentiate those many times, and then third step, eliminate arbitrary constant using the derivative equations. Eliminate arbitrary constant using the derivative equation. Derivative equation, what we have already found using the derivatives. Okay. So let me take one example quickly. There are two ways. One is by direct elimination, and the other method you can use is by determinant. So at least one method I will tell you first, and then we'll go to the second method a bit more. Yeah, so let me give you the example. Y is equal to say, write down the question only. Form the differential equation. Form the differential equation. Form the differential equation whose general solution is. Form the differential equation whose general solution is a e raised to minus 2x plus b e raised to minus 3x. A e raised to minus 2x plus b e raised to minus 3x. Okay? Fine. Now nothing is mentioned, that means a and b both are arbitrary constants. A and b both are arbitrary constants. Okay? Clear?
Yes.
Yes, ma'am.
So you have to eliminate both. How many? So step one, what you have to do? Identify the number of arbitrary constants. There are, yeah. I'm writing it for the first example. There is no need to write such type of things. There are two arbitrary constants. Okay. Step two is differentiate twice. Differentiate given solution, given general solution two times. So let us do that. Okay. So y1 is equal to minus 2a e raised to minus 2x.
Minus 3b.
Okay. And minus 3b e raised to minus 3x. Then one more time, y2. That is 4a e raised to minus 2x plus 9b e raised to minus 3x. Now still but a and b are not eliminated. So you have to try to eliminate. So if you do it this way, there is a method of determinant. These are three equations. This is equation 1, this is equation 2, and this is equation 3. We solve this three equation by determinant method, writing it in homogeneous equation form. So that is a e raised to y minus a e raised to minus 2x minus b e raised to minus 3x is equal to 0. Taking the determinant equal to 0. y1 minus or minus plus 2a e raised to minus 2x plus 3b e raised to minus 3x equal to 0, and y2 minus 4a e raised to minus 2x minus 9b e raised to minus 3x is equal to 0. So we'll solve it with the determinant for eliminating a. So I will take the coefficients of AB and this values as the third column and try to equate that determinant equal to 0, which will eliminate AB by your Cramer's condition. Okay. So what is that? First is y1, y2, then it is minus e raised to minus 2x and minus e raised to minus 3x. I am eliminating a and b with the help of this determinant. Then y1 is nothing but what you say 2 e raised to minus 2x, 3 e raised to minus 3x, and this is minus 4 e raised to minus 2x and 9 e raised to minus 3x. This determinant you have to solve, and that will give you an equation which will relate by y1, y2 and x1. Okay, so how many of you all know how to do this? From this differential equation, from this determinant, you can take common terms. E raised to minus 2x you can take common, and e raised to minus 3x you can take common. So taking that common, I am writing it here. Okay? Taking it common, we will get the determinant becomes e raised to minus 2x and e raised to minus 3x. If I take common to minus raised to minus 5x, that will remain outside. Y1, y2, and it is what remains inside is minus 1, 2, minus 4. Then it is minus 1, 3, 9. And this determinant is equal to 0. Can this become equal to 0 anytime? E to the power e raised to ax, is it 0 anytime for any value of a?
No.
That is never 0. So only this determinant is equal to 0. Solve this determinant, that will give you the answer. 18.
This time minus 9 should be there.
Yeah.
Ma'am,
Minus
minus 9
9.
will be 9.
Minus 9.
Minus
Okay. Yes. Correct. Right. So it is minus 18 plus 12. Minus of minus plus 1. Delete first row, first column. Minus 9y1. Minus 3y2. And minus 1, delete this row, this column, minus 4y1 and minus 2y2. Simplify this is minus 6y, minus 9y1, minus of minus plus, so minus 5y1 and minus 3y2 plus, so minus y2 is equal to 0, or y2 plus 5y1 plus 6y is equal to 0. That is your differential equation. What is the order of the differential equation? Y2 means what? d2y by dx square, na?
Yes.
So y2 means d2y by dx square. So order of the differential equation is 2. Highest order is 2. How many arbitrary constants are there? 2. So we are right. This is one method when you feel that this will be easier to do. The other method I feel is many times easier. Okay. So is this clear? This method, determinant method? Take the, remove the coefficients, put it in the determinant equal to 0, and e raised to powers are common. You can take it outside. E raised to ax is never 0. So simplifying that, you get the answer to be as expected. Y2 plus 5y1 plus 6y is equal to 0. Okay, fine. 5 minutes are there. I have to also take attendance. Just quickly, should we take it? The other method also for this example? Yeah.
Ma'am, for the other method, we have to multiply the second equation by 2. We can do it.
Second equation by 2.
And
Go
then
ahead and tell me.
add 2 and 3.
Same type of differential equation, and you are saying that elimination by cross multiplication, you are saying.
Yeah.
Yeah, that is also there, but still it will be a bit lengthy, I feel. Just see what I am doing next, okay? This is method 2.
Multiply by e raised to 2x.
Absolutely right. This is very easier way, I feel. Okay, this is given in your books, that's why I told you, but this is rather easier. Y is equal to a e raised to minus 2x plus b e raised to minus 3x. Okay, so what I will do, I'll make this constant alone, a and b. Sometimes it is not possible to make it, so that's why this method is also told. If suppose x was multiplied, then also then this method will become easy. But for this example, at least when a and b can be made individual, that means you can remove e raised to minus 2x by multiplying by e raised to 2x everywhere. Let me see that this will become like this. Multiply this with e raised to 2x. Is this okay?
Yes, ma'am.
Everyone, समझ में आ रहा है ना? हाँ.
Yes,
So now we will differentiate. Yeah, now we will differentiate. This is equation 1. So differentiate 1 with respect to x. You will get यहाँ पे आपको u into v को use करना पड़ेगा. That you have to be careful of. Okay. So it is 2 e raised to 2x y plus e raised to 2x y1 is equal to derivative of a is 0 minus b raised to minus x. Minus b raised to minus x. Okay. Now we can make b also alone by multiplying by e raised to x. So multiply this equation by e raised to x. You will get 2 e raised to 3x y plus e raised to 3x y1 is equal to minus b. And now differentiate equation 2. Differentiate 2 with respect to x. What do you get? What will get? 6 e raised to 3x y plus 2 e raised to 3x y1 plus 3 e raised to 3x y1 plus e raised to 3x y2 is equal to 0. समझ में आया? यहाँ पे प्रोडक्ट रूल यूज किया मैंने. 2 as it is, e raised to 3x का डेरिवेटिव 3 e raised to 3x. So 2 into 3 6 e raised to 3x as it is, y वैसे ही रखा. Now I'll take the derivative of this y. So what's the derivative of y? y1. So 2 e raised to 3x as it is, y1. Derivative of y is 1 plus. यहाँ पे अभी product rule. So what is that? E raised to 3x derivative is 3 e raised to 3x y1 as it is plus e raised to 3x as it is y1 का derivative y. And derivative of minus b is 0 because it's the constant. Now you remove e raised to 3x out and what will get? So e raised to 3x अगर कॉमन ले रहे हैं तो 6y plus y1 के साथ मिडल दो टर्म्स दोनों ही y1 के साथ है. Both of them are with y1. So 2 and 3 5y1 and plus y2 is equal to 0. Again e raised to 3x is never 0. Therefore the required differential equation is nothing but y2 plus 5y1 plus 6y is equal to 0, which is same as the one we got by the determinant method. Is it okay? So this is a bit shortcut only. You have to be careful while taking the derivative of product rule on left hand side. Is it okay?
Yes.
Everyone?
Yes.
Okay. So I'll share more examples on this, and that is about the formation of differential equation. Solution of differential equation we'll see maybe tomorrow or in the coming lectures. Okay.